was saying?
I don't remember, but I think I was asking that the like after it loses the alpha hydrogen, the entire second molecule attaches itself to that first molecule.
Yes. Where it attaches is the carbon of the C double bond. That's the reactive center.
Okay.
So once you got your anchor, okay, this is the C double bond O wala carbon, this becomes single bond. The rest of it will remain as it is. So if it is aldehyde, this becomes CH. क्योंकि ये ketone है, this carbon is attached to two other CH3, so just put CH3 here. Okay. And इसका alpha hydrogen is OH. Yeah.
But what if it was an unsymmetric ketone?
If it is unsymmetric, the reactive center is still the alpha hydrogen only.
Okay.
But on which side? Is it going to be the CH3 side or is it going to be this thing? In that case, you're going to get all the different permutations and combinations that are possible. So that's where you end up with. So that is the next reaction, which is cross aldol condensation.
Wait, can you show like the product after heating also?
हाँ, condensation product ना. ठीक है. So when you heat it, condensation matlab there's water lost. So water is lost, matlab this OH is lost, and another hydrogen from again the alpha hydrogen, the alpha carbon only. So one of the hydrogens from here is lost. So the whole
alpha hydrogen is all of them, right?
no,
CH3,
alpha
CH3,
to the C double bond on this side. Like always, hydrogen is lost from adjacent carbon, right? There you apply Setzer rule. So whichever carbon atom has lesser number of hydrogens, always lost from that particular carbon. Always happens to be this carbon that is right between the OH and the aldehyde, the C double bond. Okay, so that's CH3. Then this is lost. So this will still have the CH3. तो यहाँ पे double bond आ जाएगा. And CH2 में से एक hydrogen loss मतलब I get CH. And the rest of it remains the same. You have C double bond O and CH3. Yeah. So cross aldol is when you like यहाँ पे we are mixing with the same molecule, right? I took only acetaldehyde in the previous example, acetone in this example. So if you take different aldehydes or different ketones or a mix of an aldehyde and a ketone, so that's cross aldol condensation. So in that case, you get 4 different products, which is basically the permutation combination of all the possibilities. So for example, if I take CH3 CHO plus CH3 CH2 CHO, then again on heating with like dilute NaOH, I get 4 different products. So one is keep this constant, keep the acetaldehyde constant. So I get CHO, CH2. So if I lose the water also, this becomes CH double bond, and then यहाँ पे CH, CH2, CH3 plus the second case, CHO, propanol will be the this thing, the one that loses alpha hydrogen. So यहाँ पे alpha hydrogen gone. This is connected to another CH3. And this will be attached to acetaldehyde. So यहाँ पे double bond CH3. So this is like one set of products. Along with it, the self, like the regular aldol condensation products also. Like what if CH3CHO reacts with another molecule of CH3CHO, so that product, and what if this reacts with another propanol, that is the other product. So you'll get a total of 4 products. Yes, no. So the reaction mechanism, everything is the same. The only difference between aldol condensation and cross aldol condensation is, you can think of it as 2 points of difference. One is aldol condensation may you have only a single reactant. You're just heating one aldehyde or one ketone with dilute NaOH, and then you end up getting uska corresponding product. Cross aldol mein you're heating 2 different aldehydes or ketones, and you're going to get products, a mixture of products, because like you have reaction happening between all the different molecules. So CH3CHO plus like acetaldehyde plus propanol, say you'll get the 2 possibilities, and then you get products of the self aldol condensation of acetaldehyde itself and propanol itself. Okay, so 4 different possibilities of products. And then final reaction. So aldol condensation is specific to if it has alpha hydrogen only. The last reaction is Canizaro's reaction.
1 second, can you go back?
Oh, done yet.
Miss, it's 6:35.
Yeah. One last reaction, so we'll finish it off. And this is a simple one, like you don't have mechanism or any complicated stuff. Sia done?
Yes, ma'am.
Huh. So the last one is Canizaro's reaction. So this reaction this occurs with aldehydes without alpha hydrogen. So with alpha hydrogen, you get aldol condensation. Without alpha hydrogen, you end up undergoing Canizaro's reaction. But the reagent is the same. You just heat that particular aldehyde with concentrated alkali. So simplest this thing is formaldehyde, because you have hydrogen on both sides, you do not have an alpha hydrogen. So when you make this react with concentrated alkali, like for example concentrated KOH, so this will undergo disproportionation reaction. Do you guys remember the definition of disproportionation? What is disproportionation reaction? Quickly.
One reactant will give several products.
Specifically, what happens to that single reactant? Like, how is it different?
It undergoes reduction and oxidation.
The same species undergoes reduction also and oxidation also. So here also it's the same funda. So this is disproportionation. So you end up getting a reduction product, which in this case is an alcohol, and an oxidation product, which is a carboxylic acid. Because you're heating with KOH, you get the carboxylate solute. So this is the reduction product. This is the oxidation product. So because it's the same formaldehyde undergoing both reduction and oxidation, this is disproportionation. So if you observe it, the reaction is the same. So when you heat aldehydes with an alkali, so you see whether there's a whether there's an aldehyde, alpha hydrogen or not. If there is alpha hydrogen, you end up getting aldol condensation. If there is no alpha hydrogen, it ends up undergoing Cannizaro's reaction. Okay. And after this, we have electrophilic substitution. Just one point about it. So if you have aromatic aldehydes or ketones undergoing electrophilic substitution, what product will you get? Suppose I have benzaldehyde. What product will I get on electrophilic substitution? Quickly guys, like this is the last. We'll end this once you have this.
What are we reacting it to?
Any electrophilic substitution, say Cl2 in anhydrous AlCl3, for example. AlCl3.
Fluorobenzene?
No. This is a substituted benzene. Jahan pe you have C double bond O group substituted here. So how is the electrophilic substitution directed?
CHO is, I don't remember. Orthopara?
No. CHU, meta, electron withdrawing.
Meta, yeah.
So COOH, all of them are electron withdrawing. So you end up getting a meta substituted product. So electrophilic substitution with aldehydes and ketone groups substituted on the aryl group will always give meta products. This I'm not going deeper into it because we've done so many of these reactions. Sulfuration, nitration, chlorination, acylation, alkylation, whatever you take, as long as it's electrophilic substitution, you always get meta product. This you need to revise it. We've been doing this since grade 11. So yeah, that is the last thing. Okay. All right. So tomorrow we'll start with carboxylic acids.
Thank you, ma'am.
Okay.
Thank you.